Now, is there anything else that you want to ask on today's paper?
Not really. Yeah.
Okay, then let's forget about it for a while until tomorrow lah, when we have to discuss paper 2. Okay. Okay. Yeah. Let's focus on chemistry for now. Okay.
Yeah.
All right. Now, how are you feeling right now?
I don't know.
Tell me more.
Like, I don't really have a particular so-called like feeling right now.
No, it's okay. It's okay. I mean, I guess what I meant is, how are you? Not necessarily your feeling.
How am I? There is concern, but yet again, I'm a bit like confident, which is weird because I looked at the O-level questions for chemistry, where they seem manageable, but then you never know. So
it is true that you'll never know, but like the A math question today, right? You'll never know, lah. They seem to be quite creative this time, at least I feel, right? But
I could do, I think, practically all of them except for one. Yeah.
Which is a good indication of your stamina, your energy, your ability to read. I think today
it's not the cosine graph one either. It's not the thing where you draw the two graphs together. It's not that one.
That one's standard. No, that one's standard. The other questions are interesting. Interesting. But
there was no trick.
There's no trick. What do you mean?
There was no trick in the thing other than that drawing. There was no trigonometry.
Oh, there's another one. The one with the CRT 120 centimeter.
I don't count that lah. That one is like a bit. I mean, I guess that's trigger, but like
it starts from there, I suppose.
But it's also not really like trigger. But like I don't know, maybe tomorrow.
Yeah. No. My point is this. My point is not AMAT. My point is not AMAT. Forget AMAT. My point is that reading is very important for today's paper. I feel if we read properly and we understand the question and accept it properly, doing it is not a problem.
Yeah.
But the reading is very important. So I'm glad to hear that you seem to be reading well today. Tomorrow you will be needing to read. And to be very clear, section A, again, standard stuff, right? Reading is important, but standard stuff. Section B, yeah. So strongly suggest we go as planned. Section B is totally unpredictable. Correct what? That's what section B is meant to be, right?
Yeah.
45 minutes, read first, do the choosing first. Standard, right? That's the plan. That's how we manage, and that's how we give our best on the reading part. Then section A, you can do whatever you want.
Okay.
Right. As for you think that the TYS or prelims are manageable, I believe section A should be quite okay, right? But again, section B, again, a lot of reading. So I hope what you meant is that you can manage the reading and the understanding reasonably well.
Yeah.
Now, having said all that, if you don't have any question right now, it's okay to just stop. But if you do have a question, like yesterday, I will be with you until later.
What are the conditions for the turning off an alcohol to a carboxylic acid?
Right. So the condition I sometimes forget. So why don't we just check, right?
Check. But then there's some that say it's KMNO4, but then there's some that say it's sulfuric acid.
Okay. So the reaction that we're looking for is oxidation, right? I guess that makes sense, right? You're adding one O. there are probably three that your teacher mentioned to you. I mentioned the one that you didn't say just now. It's an organic oxidation. So it is possible to turn alcohol into carboxylic acid by living things, which is to say, from fruit juice, I'm sorry, from wine, for example. Wine has an alcohol, right?
Yeah.
From wine to not wine, a sour type of wine. It's actually, what do you call it? Oh my goodness, what do you call it? The soury stuff that we used to cook.
Vinegar.
Vinegar, yes, yes, yes. Wine vinegar, or in general, just vinegar, right? So that is not done by usually by that can be done traditionally by living things like bacteria or yeast, right? So just want to say that, right?
Okay.
Is there a condition for that? No, that's just mentioned for you to know. I don't think we're going to biology that. Those are biological conditions, right? Okay, so that's one. So the second one is KMNO4. KMNO4 is a very strong oxidation agent. So it's not surprising that it got mentioned here. As for condition, we might want to look at it. And the sulfuric acid does have potential, but sulfuric acid is very rarely mentioned in O-level, right? So are you sure you're hearing that from your teacher, or is it somewhere else, or is it TYS?
I have no idea.
Right. So why don't we simply check? No, I'll just check. Why don't we just check the condition for KMNO4 first, right? You can find something else first, right? And do something else. Right. Is there any other question?
No. I mainly just need to remember my cation and anion tests. Although anion, I pretty much remember it. Anion is like carbonate. SPA is all soluble. SPA is soluble, then the rest is insoluble.
Yeah,
Then
but
like etc.
that's not the anion test, right?
Anion is
That's
like SO2, and then
yeah.
SO2 is like
No. SO2 is gas.
sorry,
SO2 is gas.
4.
4 to minus, right? Yeah. How to detect
Yeah.
sulfate? Which is you
No,
need to
but
remember.
it ties in with like the solubility of the
Yes, barium
things.
sulfate. Yeah, it does. Once you know that, then it actually makes things easier. True.
Then yeah, chlorine you react with Ag. Uh, ammonia you just warm. Sorry, ammonium salt you just warm slightly, and then it gives off a gas, which turns damp red litmus paper blue.
Yeah, yeah.
Etc.
Did you say wet red litmus paper?
Damp red litmus paper.
Yeah, damp. Sorry, damp. Yeah, correct. Yeah, all those stuff you can revise today, but I will suggest that you revise tomorrow, lah. Right?
I mean,
like
but then there's like, I don't know, some people say that if you revise before you sleep, then like when you sleep, then it like stores it better in your head. I don't know.
No, that's true for in general learning. That's not just true for today, right? Having said that, if you revise tomorrow, you don't have to go to sleep lah, in order to make it stick, right?
No,
Right.
but then it's like you can double revise. So like tonight go sleep and tomorrow wake up. Same.
That's fine. That's fine. I don't doubt your memorization. I don't doubt. You probably shouldn't doubt it. You'll be fine.
I also found out that I could memorize the entirety of the history syllabus in 1 week.
Yes. I mean, that's why I don't doubt lah. That's why I don't doubt. I don't worry about your memorization too much. Right? For your chemistry, it's probably the other things, or it probably don't memorize everything needed. That's what I'm more worried about. But even right now, I'm not very worried. I'm not.
Okay.
So you do you lah. Doesn't mean that you shouldn't do anything. You can do what you want in this case. Now, are you sure that we do not need to do more papers or do more questions, that is still useful lah.
Okay.
If you're using a physical copy of the paper, then a video would be great.
Sorry, what paper?
If you're using a physical copy of the paper, then a video.
No, but like, what paper?
Oh, that's up to you. Unless you, I mean, you at this point, any papers that you have not read is probably going to be useful lah.
Any paper that I've not read.
DYS, DYS or prelim is probably fine. And of course,
do I
again,
mainly do section A? Because section A is more like content that you learn, rather than section B is like more of like you apply some of the content that you learn. But it's mainly if you can read.
Yeah, you're learning how to read. It's always like that one. Because tomorrow what you're reading is going to be very different from what you have read. So you're learning to read on the spot, right? And choosing the proper one, that kind of thing. For section A, if you have little doubt, you can leave section A to tomorrow.
Oh.
Then if you're feeling good right now, I prefer that you do a reading of section B lah. Right?
Oh, I think I've done 2019 yet. No. So you prefer me to do section B?
Yeah. Again, start from the the one that you're supposed to choose, which you start to read.
The either or.
Yeah, the either or one, and then you're gonna read and gonna choose. You're gonna do, and then you move on. 15 minutes, 15 minutes, 15 minutes each.
This either or is both on OChem.
Not sure whether that's good or bad, but I think you should read first before choosing. Right?
Wait, how much time do I have to read?
Just keep yourself to around, right? Remember 45 minutes, right? So that's easy to keep track in the class, right, when you're doing. And maybe the either or one slightly more than 15, then the rest slightly less than 15, right? Something like that.
Wait, guys, right here. Just the question that I asked you just now.
Oh, right.
So I guess this. So what? Then the other one should be sulfuric acid.
I guess so. Which is a little bit weird. Why is this in the syllabus? I'm not gonna guess. Can you look at the answer key? I'm not gonna guess here. If they don't name the condition, then that's fine, right? Because the moment you go to condition, that seems to be a very detailed thing for sulfuric acid.
It says sulfuric acid as a catalyst, though, usually.
I mean, well, true.
Where is question then? Well,
Yeah, but that seems out of syllabus. That's very weird. It's very weird.
it's not sulfuric acid.
Yeah.
It's
Yeah,
what
I don't think we should be
is it?
mentioning that.
So oxygen is one of them. Then it's either potassium manganate 7 or potassium dichromate.
Yeah, the K2Cr2O7. The K2Cr2O7, right? Do you not know potassium dichromate?
No, I don't remember it. K2
K2Cr2O7? Yeah. From
K.
green to orange, no?
No, I don't remember that. I remember manganate, potassium manganate 7. Then that's from purple to colorless.
Yeah, the colorless is the Mn what?
KMNO4.
No, MnO4 minus is purple. The colorless one is
Uh,
Mn2 plus.
oh,
That means the ion change, the ion change from MnO4 minus consumed, right? Consumed, reduced, right? Into Mn2 plus. That's the colorless guy. Right? Mm-hmm. I mean, he's an oxidation agent, so he can. So for the K2Cr2O7, I thought you're supposed to know.
I thought if it's reduced, then the oxidation state will be lower.
Yeah, from MnO4 minus, its oxidation state is 7. To Mn2 plus, its
Oh,
oxidation is 2. Right?
KMNO4.
Is
Like the
MnO4
entire thing is
minus.
minus.
Yeah, MnO4 minus. So that's not the oxidation state, okay? It's the oxidation state of the Mn, which is we're concerned.
So it's plus
7.
7 to
Yeah, plus 2.
uh
Mn2 plus. Right? Make sense?
yeah.
This, I think you should know, yeah.
Then what about
If this
potassium
is,
dichromate?
right,
6.
write down quickly. KCr2O7 2 minus lah, because it's K2Cr2O7 lah. So it's Cr2O7 2 minus, which is oxidation state 6 lah. That's why they say 6 lah. K2Cr2O7. K2Cr2O7, if you want to write the 2 minus, the K2 shouldn't be there. Make it clear. Don't do it this way. You're confusing yourself.
What?
If you want Cr2O7 2 minus, there is no K.
Oh,
If you want K2Cr2O7, then the 2 minus is not there. They mean the same thing. What you're writing is totally wrong though. Okay, right? You understand what I'm saying?
sorry.
It's either K2Cr2O7, which will become Cr2O7 2 minus lah. Right? The K plus will detach because this is soluble in water, so the K plus will detach. SPA.
Okay.
Are you okay with this? This is not new.
A bit, yeah. Then what's the oxidation state of Cr?
6 lah. As written lah. Cr is
this
6.
is also 6.
Why are you so surprised that in both situations it's 6? They haven't changed a bit. Changed a bit. This is not the changing of the ion. This is not the reduction of the ion. The K plus is just detaching from the negative ion.
But potassium dichromate is also, it's an oxidizing agent, but it doesn't need to be.
Yes. Which will oxidize into CrO3.
Okay.
Right?
So it oxidizes to CrO3.
Yeah. So I remember the minus first. Although this is the rarer dry, I thought you're supposed to know.
I only remember potassium manganese. And I mean, it should be also H2SO4 as a catalyst, though.
Catalyst means that it is not the guy oxidizing.
Speed up the reaction. Yeah.
Yeah. So it doesn't count if that's what they mean.
Then for alkane to alcohol, which is hydration, it's the catalyst is hydrogen phosphate.
I'm sorry. Let's stick to the potassium dichromate first. Going to memorize properly. It becomes CR3 plus. I made a mistake just. It becomes CR3 plus.
CR3
plus. This is from green to orange. This is the CR getting reduced. Make sense?
Okay.
Right? From 6 to 3 lah. Green to orange.
So 6 here, 3 here.
6 there, 3 at CR3 plus. You're confusing yourself. The K2CR2O7 is the same thing as CR2O7 2 minus. Why are you very confused here? What happens to K2CR2O7 in the water?
The K2.
The 2K plus, you mean?
Oh yeah, the 2, it becomes 2K plus the
detaches, right? Detaches because it is soluble. So the K2CR2O7 becomes CR2O7 2 minus.
Okay.
Because of solubility. Is this okay or not?
Yeah.
Then only at that state can he reduce, oxidize something. He himself will get reduced to CR3 plus. No?
Okay, so the
From 6 to 3
gets changed, so it gets reduced.
From 6 to 3.
Okay.
Right, from green to orange.
So chromium gets reduced from 6 to 3.
Yes.
Okay.
Right. I'm not sure whether this counts as two substances, the manganate and the dichromate, but the first answer, which is oxygen, refers to the organic oxidation done by yeast, right? Done by yeast. Okay, so at least know these three. I think you should forget sulfuric acid, by the way. It doesn't seem to be in your syllabus.
Okay.
Okay, let's get that clear first. Okay, what was the other question? Sorry.
I don't think I had another question.
Now, still back to reading. We're not doing here. We're still reading. Of course, noting the answer is nice, but still read. You are asking on the condition, for the oxidation, right?
Yeah.
The condition is alkaline with heat.
Yeah.
Yeah, that's it. So KMnO4 is the oxidation agent, but it will be in an alkaline situation, usually by adding KOH, and then add heat. And then I guess that's what you memorize if they ask. It's memorization. You don't understand why the conditions. Right. Would you like to write it down for tomorrow? Then we can, leave it until then.
So what the condition that you just stated?
For the oxidation from alcohol to carboxylic acid using KMnO4.
Oh. No, I know it's KMnO4 already, but then I didn't know it was
alkaline.
dichromate.
Alkaline and heat. You're asking for the condition, not the reactant.
Alkaline and heat. So alkaline KMnO4.
Yes, something like that. Alkaline KMnO4 and heat.
I wrote must be warm.
I guess that's the heat part, but also alkaline, which is the addition of KOH usually. I think usually. Right. It will be good to memorize. Okay. Right. Sorry to disturb your reading.
I think I'm done reading.
One of them, is it? Or both? Sorry, both.
Just one of them.
Right. Maybe you read two. Again, tomorrow you expect to read two, man. You don't expect both to be easy, right? So you read two and then you make a decision and then you can do that.
Yeah, I think I'm done reading.
Oh, that was fast. All right. Maybe because of organic chemistry, yeah. Which one will you choose then?
Probably the first one, because I think I just do the first one. I think it might be the harder one.
I suppose you can try, I guess.
Can I just like not write that thing? Like the
Uh,
H's?
Sorry, can you what? Sorry.
Can I just not write the H's for now?
Yeah, for now, that's fine. I understand. I understand. You're trying to do it faster. That's fine. That's fine. will increase. Sorry, oh, the reduce. Okay, right. Sure. Okay.
It says suggest how one of the products of this unwanted reaction could be used. Never said like in
Like two or
like
H2, right?
daily, yeah, but it never said like daily lives or anything or like
No. As long as it is useful,
so can I just say CO2 can be used to grow plants? I don't know.
yeah. Well, that's not wrong. It's not wrong, the increased level of CO2, which causes global warming, right? We don't like that, but it also increases the growth of plants. That is true. Just for practice purposes, before you look at the answer key, maybe there's a use for H2 because you did learn an industrial use of H2 in chemistry. You did. It's a very obscure chapter.
The manufacturing of
Manufacturing of
can be used in
manufacturing of
manufacturing of ammonia.
yeah. Although the amount will not matter here, right? But we're just told to suggest something. So all right. Okay, that's your answer. Right. So check the answer key lah.
Wait, ammonia is for fertilizer.
It is not always, but I think that's what you learn mostly. Right? Yes, and that is mostly what we are interested in. Yep.
It's not supposed to mention HI.
Not supposed to mention HI. Sorry, why is there an HI here? Sorry. What?
It's the catalyst.
The catalyst. Yeah, because the HI does seem to be regenerated lah. Yeah, you should be scratching HI on both sides. Why are you not canceling them from both sides?
Oh.
Right, HI and HI. Right, that is an indication that it's a catalyst lah. But most importantly, you can just cancel them, and therefore you're correct. No,
What's this about catalyst being regenerated at the end of the reaction?
Yeah. HI, because catalyst, this is a more proper view of catalyst. Catalysts are reacted, but they reappear. They reappear. So they become a medium. They become.
So the fuller answer I wrote did not partake in it because
that's wrong. That's
it
wrong.
Reappeared at the end.
That's the wrong verb to use. It is the wrong verb to use. I don't think the answer key will be saying it like that also.
They said regenerated.
Yeah. So regenerated, just to avoid, wrong words, we should use the word regenerate. Because again, it did partake in the reaction. That is a proper view of catalyst. It is wrong to view catalyst as not doing anything. That doesn't make sense actually.
But it says after that, this shows that it did not take part in the reaction, which is a characteristic of a catalyst.
I'm sorry. This is where do you? I know.
Answer booklet.
Yeah, just don't do that. Just don't. I mean, just don't say that. At the very least, you must use a disclaimer when you say that word, right? Catalysts do not partake in the overall reaction, right? Which again is not a useful view of catalysts. It is not. Regeneration is a much better use. When you say regenerate, you don't have to say do not partake already. because regenerate actually means you partake and then you reappear.
So it does not partake in the overall.
Avoid. Just avoid that phrase.
Okay.
Just avoid it.
But then
Because
everyone is kind of like taught that phrase though.
just say regenerate. Okay, just say regenerate, right? And no, just say regenerate. That's it. No, that's it. Let's just say regenerate. Right. Just say regenerate.
Okay.
That's the appropriate view of catalyst.
Okay.
And never mind the syllabus. This one, I'll make it short. Never mind. In A level, you will not remember the not partaking anymore. Every catalyst partakes. They even ask you to go and find the reaction. So they're not very interested in the overall only. Something.
Okay.
So again, back to answer key.
I marked the other two. But then for this one is more specific in the answer key because it's like I said, CO and H2O are needed in the reaction of that to become that. But then the answer key is like more specific. It says CO and H2O are used in stages 2 and 3 of the process and are being
Above,
used
right? Above, right?
above.
I will argue that simply means a better reading, no? I think your reading and noticing that it is there should be part of.
I noticed it was there, but then I didn't write it as being that specific, I guess.
I think you should, as in that is something useful to do tomorrow in the process of reading.
Then for part 2, it says H2 can be used as an alternative fuel or as a
True.
reactant for the manufacture of ammonia. But then it said it also mentioned it also was like a bit more specific. It says in the Haber process.
Never mind. I mean, Haber is nice, but you know, he's just being very specific lah. But fair enough, you know, so that tomorrow we cover everything. Please mention that, no? Because Haber process means you meant that specific nitrogen plus hydrogen reaction, right? So maybe you can say you don't have to say Haber if you just write the reaction. Maybe that's why they want to become very specific.
Okay.
Never mind, just follow lah. Just follow. That one is fine. Right? But the part B1, you're not just following. I think he's doing the right thing.
Okay.
Remember AMAT just now. I'm not talking about AMAT. I'm just trying to recall you the first question, the completing square.
Yeah.
It was 2 marks and then 4 marks for the second part, lah. Right?
What was the second part?
Suffice to say, the second part, if you use the first part, the completing square, no, it will be slightly easier and more direct.
Oh.
That I'm going back to the process of reading, especially for a long question like this. You know that they are all interconnected, nah? That should be the assumption. So it's not a surprise. In fact, you should actively look for, should I be using the one above? Should I be using the one above? There was like 2 other questions in AMAT just now that if you use the one before, things become very easy. At least I find it that way.
Okay.
Right. My point is, this is not just Chem or AMAT. This is reading a long question. That's how questions are structured. That's how the question maker will see it.
Okay.
All right. For tomorrow, especially section B, please assume it that way, lah.
Okay.
Right. Okay. Correct. You're happy with this?
Yeah.
Let's move on to the 2 other questions.
But then, was it like, okay, the salt preparation? I don't know why I suddenly thought of this. Right? Salt.
Yes.
For salt preparation, right? Precipitation is like you have once soluble plus soluble to form insoluble. Then you just put in the
Yes.
evaporating dish. Eh? No, you can filter it out.
You should filter it out and then you wash it and then you dry it, right?
Yeah, but then like let's say like soluble plus soluble to form like soluble, right? Then obviously it's titration, right? But then how do you just get one salt at the end?
Right. So be very clear about titration. So first thing first, in titration, if you titrate with the wrong two things, right, you will
Yeah.
get too salt.
Oh,
Right? You'll get the wrong two salt, right?
so
But
at the end of
that's
the day,
why
if you
that's why titration is neutralization. That
oh
means there is no two salt. There's only one salt plus water, for example.
okay,
Then there is no other salt, so to speak. There is no
okay.
other salt.
So then you just put in evaporating dish, just heat it, and then crystals start forming at the
Yeah,
bottom.
yeah,
Uh,
yeah.
and then you filter out the crystals, wash dry.
And then what? Yeah, same standard thing, you know.
Oh,
True. Those are usually section A stuff, but they can always put it in section B. It is true that section B mostly, almost always have OChem, but any topic they can put in. Any topic. Pollution, they can. Energy, they can. Catalyst, they can.
what's
Reversible
energy?
reaction, energy of reaction, delta H,
Oh,
negative,
oh,
positive, the
yeah.
curve, right, which usually appear in section A. They can put it in section B. Oxidation state and ammonia, sometimes it happens. Pollution, definitely. Structure, sometimes it happens, right? I mean, the point is you must be ready for anything for section B, and that's why. But
Blast
OChem,
furnace.
I'm sorry.
Blast furnace.
Blast furnace, although rare, that's the metal. That's for the making of iron. They give you a alternative blast furnace. That means something similar to the blast furnace of iron, but for making of like what was that? For the making of aluminium or something.
So
No, not
are like
aluminium.
the
Making
things
of
still
something else.
are the things still the same, like coke
Similar,
and
not the same.
then limestone, and then like
Similar. No, not guaranteed. Remember, it is supposed to be similar, not the same.
oh
This is, you should be expecting that, especially for section B. He will draw on something similar.
oh
And you will have to use your logic on the similar thing, but don't expect the same thing. And don't expect a copy and paste. You have to think.
okay.
That's why the reading becomes important.
Also Fe2O3 is the main thing for iron ore, right? The main.
Yeah, not F3, not Fe3O4. Fe2O3 is what you learn in your syllabus more appropriately. It's
But
a
it's not
hematite.
like, but also not FeO, right? Because it's
It's
not
not.
iron too, right? Yeah.
So I wouldn't be surprised, for example, tomorrow they decide on this topic in section B, then they will bring in all the other iron oxide. I wouldn't be
Oh,
surprised.
but the main one that I need to know is just hematite, right? Mainly
No.
Fe2O3.
Yeah, well, yeah, in section A. In section
Oh,
B, they give you, something new, and then they will try to give you more information so that you can process it.
oh,
Something like that. That always happens. Right?
okay.
Right. Be expect to be surprised, that kind of thing. Expect, oh, this is a new thing. What is this, man? What is this? Yeah, it's a new thing. What? That's section B. What? Electrolysis, cell, all sorts of stuff. All sorts of stuff. I've seen all. So again, let's practice more. Let's practice. All right.
Okay.
Come, let's practice.
This was like before COVID, right? So that means we should have everything in my syllabus, I guess.
If you're talking about section A, then no surprise lah. But again, we're trying to have to brush up a bit on section B.
I don't like this type of section B question. Or is it? It's like this kind of one.
Yeah,
it's like very long.
I know, but there will be one super long question. Not the choosing one usually. The choosing one will be about equal. If not, then you just avoid that, right? There will be one unavoidable long read.
So speaking of the
Blast furnace, right? Speaking of blast furnace.
Oh.
Speaking of blast furnace, and then this
Oh,
Kylo, the crude oil thingy,
I
this
think
is
I'm
this
about
is
I'm more comfortable with crude oil, so I'll
right.
do blast furnace.
Uh-huh. By the way, Mike, for tomorrow, just for the sake of tomorrow, when you're still reading, right? You should be reading all and just read the answer key lah. Because it seems that you have not done all this before.
No.
Then for the process of just absorbing more and more, read first both and then read the answer key.
Oh,
I mean, it's slightly lower quality than thinking about it, but what to do? We don't have much time.
okay.
You can do that after tuition. Right?
Okay.
Yeah, so just reading, understanding, read the answer key. Oh, like this, oh, like that. Read again, read again.
So I ask you, right? Could I
Mhm.
just like say out the general idea of this? Because I feel like my idea of this is not that it's not worth like 5 marks there.
Mhm.
So it's like it's just describe and explain how the process separates, right? It's like I don't know, long chain hydrocarbons cracking, and then
You don't
it,
mention cracking in fractional distillation. You're already wrong.
huh? Really? Oh, sorry, long chain hydrocarbons broken down into short
When
chain
the moment you
hydrocarbons.
mention broken down, you're already wrong. What's going on?
Huh? Then
Do you know what you're talking about?
then
Cracking is the breaking of long chain hydrocarbon. That's not fractional distillation. What are you talking about?
then fractional distillation is a separation.
Yeah, separation is usually no chemical reaction. You're
Oh,
just separating, creating new stuff.
okay.
So you're wrong.
So
Lah.
okay.
Why don't you just read the answer key? At this point, we don't have time. Just read
Oh,
the answer key. I think you misunderstood something.
it says crude oil is a mixture of hydrocarbons with very different boiling points. Crude oil is strongly heated in the furnace to more than 350 degrees. Vaporize hydrocarbons before passing into fractionating column. As hydrocarbon vapors move up fractionating columns, vapors cool down, condense at different temps. Hydrocarbons with lower boiling points condense at higher sections of fractionating column than hydrocarbons with higher boiling points. Each fraction consists of a group of hydrocarbons with similar molecular mass and similar boiling points.
That's correct. Make it into vapor. Let them condense at different places because they are different at the originally they're already different. That's our non-formal, informal summary lah. Do you understand this, or this is like something you miss?
I don't know, I understand this
I'll leave it to you to memorize lah.
one.
This is
Because I thought
almost pure memorization.
I needed to state that how the vapors came about to be.
The vapors came about to be because you vaporized them with heat, not because you cracked them. You
But I
are
thought it's the
misunderstanding
cracking of
something.
crude oil.
You are misunderstanding something. I'm being straightforward because we don't have time. You misunderstood fractional distillation. Cracking is a chemical reaction. Fractional distillation
Distillation is a
is not.
separation.
Yeah, it's physical.
Okay.
Liquid or solid lah, to vapor, and then vapor condense back to liquid or very sticky liquid.
Okay.
All right, physical and chemical, they are different.
Okay. I'll just do B10 now because I'm less comfortable with
Feel
blast
free, feel
furnace.
free, feel free.
Sorry, I
Yes.
don't mean to ask while doing the question, right? For this is explain with the help of equations why coke, which is just carbon, is essential to the process of making iron from hematite, right? Do I need to
Mhm.
also show how the calcium carbonate, calcium oxide reacts with silicon dioxide to form CaSiO2 or not?
Uh, because coke.
CaSiO3, because
I
technically
feel that
SiO3 is part of
I
the.
feel if you read all the question, which you did not yet, I feel if you read that, you wouldn't have to ask that question.
Oh no, I know it's also here, but then do I need to put it here also, or do I need
What do you think?
uh maybe not?
Yeah,
I mean
because
they
of the
ask it,
one at B.
but then it's just to be safe lah. Just like I don't know, I asked that,
Feel free, feel free.
so I can also write it up here.
No problem. You will have enough time, lah, I suppose. Like that's not time consuming. Right? That's not rather than you know flip and flop about it. Might as well just do it lah, right? Your reaction lacks something, or the state symbol, which is very important. It's not
Oh,
okay to lack the state symbol. It's not okay. Especially for this kind of question, yeah, they want the state symbol. They want it nice, nice, complete lah, basically. The CaCO3 one doesn't belong here, by the way, lah. The CaCO3 one belongs more towards the when you have to mention the silicon dioxide. So it
yeah.
is a bit confusing, lah. It's a bit confusing there, right? So I suggest that you don't put it here, you put it on the right hand side, lah.
Oh,
Just move it. Don't have to rewrite. Don't have to rewrite. And just tomorrow if you want, something like that. Yeah. Okay. Your FE result being solid is wrong.
it's liquid.
Yeah, it's very hot. The reason being, lah, right? Your Cals, oh goodness me, your CaSiO3 solid is also wrong.
Slag is also liquid. Oh yeah,
Your
it is.
Then the two liquids separate, they don't mix, and therefore you can have separation of
Because
impurity
one is
from
a higher density. Yeah, okay.
something like that. Right? Be careful tomorrow. Right? Yeah, you should expect this to appear at least in section A, man. Right?
God, sorry, what is this question?
Part C, is it?
Yeah.
The first sentence, not surprising, yeah?
Yeah.
Then second one seems to be new, so we just take it lah. Don't be surprised that there's a new thing. Be surprised, but don't be so surprised. This is out of syllabus. Why are you surprised?
Because why would it make sense to use new steel to make new steel?
What do you mean by new steel
This
to
is
make
give
new
reasons
steel?
why it is important to use scrap steel to make new steel.
Wait a minute, you don't get your own syllabus. That one I a bit object already. You're comparing scrap steel for new steel, which seems to make sense with you, right? That
Yeah.
seems to make sense. You're comparing with new steel to make new steel. Well, first of all, if you already have new steel, why make new steel? That's your
Yeah.
objection, right? Yeah, but that's not what you learn. What are you talking about? Before you have new steel, what do you have? This is your syllabus.
Pure iron.
You're a bit nonsense, right? If your syllabus starts from pure iron, let me put it another way. Before you have pure iron or new iron, what do you have?
Iron ore.
Is this leading anywhere to you? I'm giving you too much hint already. If you don't get it, then you don't get this mark, no? Let me phrase my hint. This is the last hint I can give you. If you don't get it, you check the answer key tomorrow. Let's say you want to think about it today. That's what you want to train, right? You want to train. Where is this going? What am I supposed to compare? How am I supposed to structure my in this case my thought, my reasoning, right? It's almost like a debate here, right? So give reason why is it important to use scrap steel to make new steel versus iron ore to make new steel, which is what you learn in your syllabus, right? Iron ore to make pure iron to make new steel, right?
Okay.
Right. Do you have any idea?
Iron ore doesn't have the elements required in it to make steel. Scrap steel already has some of the elements within it to make steel because it's already part of steel. It's just carbon.
Sorry, because I don't see the one on top. Do they talk about what steel is?
No, they just say with
Right.
no.
In your syllabus, let's make it clear, yeah. You're supposed to know steel very roughly. Steel is iron plus carbon.
Yeah.
Okay.
Yeah. So scrap steel has carbon because it's already steel. Fe2O3 has no carbon, hence it cannot make steel.
I'll just say that I don't think you get the mark. I'm sorry, yeah, this is slightly open-ended and it feels like you don't get it. I never see the answer key though. I don't see TYS answer key one. Based on experience, so a bit unfair to you. I have experience, you don't. But I really, even like that, I feel that your answer won't get it. Now, it is up to you right now. You can look at the answer key right now. You can look at the answer key tomorrow. Just make sure you look at it. If you look at it tomorrow, you can think about it.
It's just recycling.
Yes. Iron ore has to be mined. Pollution, environmental concern, damaging the earth. Scrap steel is there. You still have to do something about it for recycling. Yeah, but because the logic of recycling versus mining should be there with you. That's why, that's why.
Well, I just didn't make the connection.
Then this is what you learn.
Yeah.
Right? No, let's move on. Let's move on. Obviously, we're learning a lot by reading section B. That is the intention. Is that 3 questions from section B?
Yeah.
Oh, okay, sure. All right. Good. Did you check all the answer key? All the answer key, not just for what you don't know. Doesn't mean that you're right, Make sure you check everything first.
For part BI, it says, what's the source of silicon impurities in the blast furnace? I wrote SiO2 or the no, but then technically it says like the answer key says hematite contains sand impurities and tremor.
Yeah,
But then it's the same thing also.
no. I don't want to debate with you. You don't get them. You don't get them. He's being very practical. You are being very theoretical. Like just now you're being very theoretical. He's being very practical. Environmental concern, very practical. The fact that the iron ore should contain dirt, which is sand, is very practical. This is a practical question. I'm sorry. I would side with the answer key this time. I'm sorry. You're not being practical.
Okay.
Yeah.
I mean, I guess that's it.
I mean, if those are your only problem, it's really not that bad, right?
I mean, I need to back up on what's it called? Blast furnace environment.
Continue reading section B. Just continue read. It's fine. It's fine. Once you read section B, you read the answer key, you will learn a lot. Don't worry.
Oh, then I'll just do it tomorrow. We'll just
Yeah. I mean, now it's time. Now it's 10. So this is just to emphasize the fact that we still have a lot to learn. Doesn't mean that tomorrow you'll do not well. No, that's not what I mean. But every time you read section B, you learn something. Because section B by nature is comprehensive. They try to test every nook, cranny, detail, new stuff, old stuff. That's why section B is good for learning. If that is what you're lacking, that would be great to do tomorrow.
Okay.
All right. Anything else, Michael?
Well, I don't think so.
Do you think you can sleep well?
Sure.
I certainly hope so. But if you cannot, just wake up a bit late. That's fine.
Okay.
Okay, you need your strength for tomorrow. That's why I'm insisting that you sleep enough, whether late or not late, because you need your strength for tomorrow and paper 2.
Okay.
Right. So, like that. Okay. I'm glad to talk to you in the middle of O level, and you don't sound very, panicky. You don't sound very shaky. You really sound prepared, I would say. Not sure about meeting your goal, but you do sound prepared. If there is nothing else, I will see you tomorrow.
Okay.
All right. Send me any questions and I'll answer them. All right. Bye.